Hi everyone, welcome to the conversion of hexadecimal to octal. An octal number has a base of 8 because it uses 8 digits to represent a number. These are 0, 1, 2, 3, 4, 5, 6, 7. Whereas hexadecimal number has a base of 16 because it uses 16 digits to represent a number. These are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in hexadecimal is equivalent to letter A, 11 in hexadecimal is equivalent to letter B, 12 in hexadecimal is equivalent to letter C, 13 in hexadecimal is equivalent to letter D, 14 in hexadecimal is equivalent to letter E, and 15 in hexadecimal is equivalent to letter F. So I will now be showing to you how to convert a hexadecimal number into its equivalent octal number. So for example, we are given here a hexadecimal number AB9. So we are going to convert this into its equivalent octal form. Okay, so how do we do this? So the first thing that we're going to do to convert this hexadecimal number into its equivalent octal number is to convert first this hexadecimal number into binary number. And then, okay, after converting this hexadecimal number into its equivalent binary number, the converted binary number shall now be converted to its equivalent octal number. Okay, so we have here our hexadecimal number A, which is equivalent to 10, B, which is equivalent to 11, and 9. Okay, next is we are going to form group of 4 binary digit in each of our hexadecimal digit. Okay, so we are going to form group of 4 binary digit in each hexadecimal digit. And we are going to use the equivalent value or the weight of the power of 2 as our index, starting from the equivalent value of 2 raised to the 0 power, which is 1. Then 2 raised to the first power, which is 2. Then 2 raised to the second power, which is 4. And 2 raised to the third power, which is 8. So this is our index for the first group of 4 binary digit. Then for the next group of 4 binary digit, we will also be using 1, 2, 4, and 8 as our index. Same with the next group of 4 binary digit. We are also going to use here 1, 2, 4, 8 as our index. Okay, so after this, we are going to add our index which has 1 under them. But, okay, in adding our index which has 1 under them, it is to be noted here that the sum of this index with 1 under them should be equivalent to the hexadecimal digit below. Okay? So since our hexadecimal digit here is 9, so we are going to put 1 under 1 and 8. Okay? So that when we add 8 and 1, the sum will be equivalent to 9. Okay, for the next group, our hexadecimal digit is B, or it is equivalent to 11. So therefore, we're going to put 1 under 1, 2, and 8. So that when we add 8, 2, and 1, the sum will be equivalent to 11. And for the next group, since our hexadecimal digit is A, or it is equivalent to 10, then we are going to put 1 under 2 and 8. So that when we add 8 and 2, the sum will be this hexadecimal digit. Okay? And then, for those index which do not have 1 under them, we are going to put 0. Okay? So we put 0 under 2, Okay, under 4. Okay, so and then for the next group, we put 0 under 4. And then for the last group, we put 0 under 1 and under 4. Okay, so this is now our converted binary number given this hexadecimal number. Okay, so 101010111001. Okay, so we already have our binary number. So what we do next is we convert this binary number into its equivalent octal number. Okay, so we have here our binary number. Okay, so after this, we are going to form group of 3 binary digits since we are getting now the octal form of this binary number. So we are going to form group of 3 binary digits. Okay, so this is our first group, the second group, the third group, and the fourth group. And then we will be using as our index the equivalent value or the weight of the power of 2, okay, starting from the equivalent value of 2 raised to the 0 power, which is 1, then 2 raised to the first power, which is 2, and 2 raised to the second power, which is 4. So this is our index for the first group. For the next group, we will also be using 1, 2, and 4 as our index. Same with the next group. So we will also be using 1, 2, and 4 as our index. And okay, for the last group, we shall also be using 1, 2, and 4 as our index. And then after this, we are going to add the index which is 1 under them. So for the first group, okay, we only have 1 which has 1 under it. So therefore, okay, it's equivalent to 1. For the next group, we have 1 under 4, under 2, and under 1. So therefore, we add 4, 2, and 1, and the sum is 7. Okay, for the next group, we only have 1 under 2. So therefore, it's equivalent to 2. And for the last group, we have 1 under 4 and under 1. So that when we add 4 and 1, the sum is equivalent to 8. So 8, 2, 7, 1 is now our equivalent octal, okay, number, okay, given this hexadecimal number. So A, B, 9 to the base of 16 is now equivalent to 8271 to the base of 8.